Greg is at the library this morning. He's at Langara. Hey, Greg.
Hey, you two. Yeah, hopefully I'm looking very scientific this morning. We're here at Langara College in Vancouver. They're getting ready for their math and science open house. It's to promote math and science and to encourage those to get an education in those fields. So what does that mean for us here this morning? Well, some swabbing about to take place here. We have some cockroaches in-house. We're going to get a physics demonstration, and maybe even, not maybe, we are going to see an explosion too. Thank you very much, you two. Lots coming up here from Langara College in Vancouver, Michelle.
Very scientific.
Can I put my hands back down now? Yeah, good morning, Don. Safety goggles, very appropriate for this live-by that we're doing here this morning at Langara College in Vancouver, where they are prepping for their math and science open house. Andrew Mosey here, a chemistry instructor, is going to talk about what just happened there. What did just happen? We'll investigate that coming up, okay? Lots coming up here, Mark.
All right, like the goggles too, safety first.
Greg Harper is at the live-by this morning. He's over at Langara. And Greg, I hear there is about to be an explosion of some sorts. Take it away.
You better believe it. Good morning, Kyle. By the way, Andrew, I think my safety goggles are better than yours.
I think they are, yes.
Yeah, you agree?
Yes.
Okay, this is what they call a gun cotton experiment. I'll let you do this, Andrew. I'm going to step aside a bit here. Very nice, you can even hear that. Okay, what just happened there?
Well, what we have is we've got cotton, but it's been specially treated in a solution of nitric and sulfuric acids. And what happens is that the molecular structure of the cotton changes, and there's extra oxygen incorporated in the structure of the cotton itself. That way, when you light this, it doesn't require as much oxygen from the atmosphere as regular cotton, and it reacts much more quickly. And as you can feel, it's like regular cotton. It feels like regular cotton.
Yeah.
We could make a lab coat out of this stuff if we wanted to.
That would not be good, especially if you lit it on fire.
What this has been used for in the past, when it was first invented, was flash photography.
Very nice.
And it can be turned into clear plastic. You can make it into a photographic film.
Okay.
It was used for photographic film in the past, but nowadays it's too flammable for those purposes.
We're going to magnify this experiment now. We are here at Langara College in Vancouver, by the way, because they're prepping for their math and science open house, which is happening on Wednesday from 12:30 to 2:30. High school students will be here. They're inviting people in the community to come check it out. They want people to get into math and to science as an education. Here we go. Am I okay standing right here, Andrew?
Maybe a little bit further back.
A little bit further back, okay. Here he goes. Lighting the match, it's lit. I'm nervous.
So am I.
Whoa! That's impressive. Thank you very much. We got lots more coming up here from Langara College, Kyle. I guess I can take these off. No, I'm going to keep them on.
That's good, Greg.
Cockroaches in the house. We've got a physics experiment taking place next. Lots coming up.
Looking forward to it. I need to pay attention this morning. Science was by far my worst subject when I was in school, so we'll check in with Greg coming up.
Yeah, thanks, Don. Go for it, Ken. Here at Langara College in Vancouver. Some cockroaches here. We have, they're gearing up for their math and science open house. We have a couple more chemical reactions coming up as well. Thor.
Hey, those cockroaches remind me of my old apartment.
That an hour ahead on Sunday, really, that was not good, and I'm still adjusting to it. Good morning, you two. I've got Jim with me here at Langara College in Vancouver, where they're gearing up for a math and science open house this week, and they're gearing up for us here this morning. We're going to learn all about this. Go for it, Jim. This chemical reaction is called elephant toothpaste. Ooh, you're watching BT. Stay with us. How long is this going to keep going? Oh, it's starting to slow down now. Can I touch it? Probably not.
All right, Greg Harper is at the live-by this morning over at Langara, and Greg, Professor Greg, we should say, is learning all about science this morning.
You better believe it, Kyle. Yes, we've got a bit of a mess here. We are here at Langara College because they're gearing up for their math and science open house, which is happening on Wednesday. Have a chemistry instructor, Jim, with us here this morning. Good morning.
Good morning.
We just saw, well, if our viewers are just joining us, they didn't see it, but a chemical reaction, and you call this elephant toothpaste.
That's right, that's right. That's actually the nickname of the demonstration. What we do is we put some hydrogen peroxide into our cylinder here. Now, hydrogen peroxide, it's actually a cleanser. You can buy it in the store. I've got about 10 times stronger, though, because chemists like to use strong stuff. And I'm going to add some liquid soap. Now, the soap is not part of the reaction that I'm going to show you, but it shows a nice effect. What I'm going to do is speed up a reaction. the hydrogen peroxide actually decomposes over time, but it's pretty boring right now. It's kind of slow. We want to speed it up. We add some catalyst, and that makes it go a lot faster.
And that sound we're hearing, that hissing sound?
That's just a bunch of steam coming off. Heat, all kinds of steam. The reaction gives off lots of heat and lots of gas.
What do we got over here?
Okay, I'm going to show you some acid-base reactions. I've got just plain old water to begin with. So nothing too different at this stage, just some water, tap water. But I want to add a couple things to turn it into a base.
This is fun, isn't it?
Yeah, it's fun to mix up chemicals. Now, what we've got is, well, it still looks like water, right?
Yeah.
But if I pour it into here, I can tell it's a base, okay, because I put an indicator in there, an acid-base indicator that turns pink when it's in base. So it kind of looks like I've got some wine now, right? Started with water, now I have my wine.
So what causes that? Is it you're mixing it up as you pour it?
Yes, I am. I had a few drops of indicator in there. Indicators are used to tell whether it's acidic or basic. You might test your pool water with one, for example.
Yeah.
Okay, what I'm going to do next is...
You only got 10 seconds left, Jim, by the way.
Make a little bit of milk out of that by pouring it into here. And
it's interesting.
Okay, now we have some milk, and lastly, some beer. And that is an acid-base reacting.
Very nice. Thank you very much. This math and science open house, Michelle, can you take me seriously with these on? I hope you can. These are safety goggles. I have to wear them. This math and science open house here at Langara College in Vancouver is happening this Wednesday from 12:30 to 2:30. They're inviting high school students here. They're inviting people in the community that may consider educating themselves in math or science.
Very cool.
There we go.
I actually take you more seriously with those glasses on and that jacket, Greg.
Thank you.
Discovering all kinds of things this morning. Greg Harper with the lab coat on and the glasses off.
Yes, and we're here at Langara College, Mark, here in Vancouver, where they're gearing up for their math and science open house, which is happening on Wednesday. Go ahead, Ken. We have ourselves a couple cockroaches here, and I have a lab coat on and you don't. That's interesting too. I know you wanted to focus on diversity of life. Oh, that feels weird.
Well, there's a lot of things we could talk about in biology. Here we go.
Is it going up my sleeve?
No, here we go. Let's put it back down.
Let's do that. Let's do that.
A lot of things we could talk about in biology, but diversity is one of them. You know, there's probably about 1.5 million forms of life that have been described on Earth, and all we know for sure is that we're only just beginning to understand. 5 to 10 million species is what's out there.
What type of cockroaches do we have here today? They're good at hiding, by the way.
These are sometimes called the giant cockroach. It's an exotic species. They're not native to here. But notice also in here we've got just a few wood bugs or pill bugs.
Loved these when I was a kid because they curled up like a ball.
Some of them curl up a bit like an armadillo. These particular ones mostly don't.
These don't.
You know, part of what biologists do is try to make sense of all this diversity. And for example, the cockroaches are insects, so they're related to ants and butterflies. These little wood bugs here are actually related to shrimp and lobster. They're crustaceans.
I did not know that.
Yeah, which are mostly a group found in the sea.
We have some sea creatures here.
I'll just give you an example of how we try to make sense of relatedness. Like most people would recognize a sea star, you know, that they have arms that tend to come in 5s or multiples of 5. If you look on the underside, they have all these little tube feet. It's part of a hydraulic system they have for moving around and clinging on to prey. They can pull apart clamshells and get inside. Okay, imagine one of these guys walking on the bottom like so. Roll it into a ball, and you have yourself an urchin. It actually has 5 rows of tube feet running up the side.
We also have a sea cucumber here.
Imagine this animal elongated, and you got yourself a sea cucumber.
Can I handle this?
You can.
Let me ask you this quick question. Okay. Whoa, whoa, what's happening here?
It's just expelling a bit of water, no worries. It's the embarrassment of being on TV.
That is very bizarre. Let me ask you this. I mean, we had that massive earthquake in Japan, the tsunami that followed afterwards. Potentially, are there any species that could be killed off because of that?
You know, I don't think it's going to be a major problem. For those that float in the water, they're fine. For those in the deeper bottom, they're fine. For the ones near the shore, I'm sure a few got smashed around, and some of the reefs, the reef creatures, intertidal creatures, will take some damage, but I think those communities will recover fine.
Okay, I'm going to put this little guy back. Coming up here from Langara College, including Kyle, a physics experiment, which is pretty impressive.
Physics. All right, Greg,
Yes.
we're upping the ante this morning, aren't we? We'll check back with you. Greg Harper's all rested up. He had a nice long weekend up in Whistler, and he's back with us this morning, learning all about science. Greg?
And here's some more entertainment, boys. Yeah, the safety goggles back on here at Langara College, where they're gearing up for a math and science open house. Liquid nitrogen ice cream. Liquid nitrogen minus 196 degrees Celsius enables you to make ice cream rather quickly. I'm going to try it. It's vanilla. And we've got a physics experiment coming up, too. You're watching BT. Stay with us. It's bubbling. Look at that. That is liquid nitrogen ice cream. I'm about to try some here. We're hanging out at Langara College in Vancouver, still adjusting to that hour ahead. Tough one here on Monday morning. We are here because they're gearing up for a math and science open house. I can almost smell that. Okay, we have a physics instructor here, Robin, with this. Good morning.
Hi, good morning.
You have a very interesting physics experiment you're going to show us.
I do.
Okay, let's do this.
Yeah,
Let's talk about how it works.
Well, this is what you call a Greek waiter's tray, and it's suspended like this, and you can put something like a nice wine glass here.
Yeah.
And would you like me to do this now?
Absolutely.
Okay. So here's the thing. Do you think I can make it go all the way around?
I'm going to say yes.
Okay. Well, here we go.
Okay, how does the glass stay on there?
Okay, the glass stays on there because we are pushing, the tray is pushing it all the way around, okay? So the key is you have to go fast enough at the top that it's not going to fall out. If I go too slow, let me do it with something else. If I go too slow, then it will fall, right? If I go fast enough, there's no problem. If I go fast enough, there's no problem, but I slow it down, well,
it falls.
We lost it, okay?
Physics, very interesting. I have to move along here to Timothy here. Good morning.
Hey, how you doing?
Earlier, I'm fine, thank you. You and Melody, you swabbed me. You swabbed my hand, you swabbed the keyboard I was working on. What are your results?
So we've cultured these with the right temperatures and with the right nutrients. And so this is the keyboard, and this is from your hand.
The bacteria from the keyboard here, the bacteria from my hand here.
Right. And of the millions that are out there, actually only maybe 1% are actually harmful, most of which are beneficial. This is from your hand, so this is your own microflora, which actually fight against probably bacteria, harmful bacteria, as in here, such as Staphylococcus epidermis, lives in your hair follicles.
I think I'm going to use an alcohol swab every time I use my keyboard from now on. Thank you very much.
Wash your hands, no problem.
All right, they have this math and science open house happening here at Langara College in Vancouver on Wednesday, this Wednesday from 12:30 to 2:30. Come check it out. There's lots to learn. Oh yeah, I've got to finish off with this. Michelle, as always, I like to try stuff in front of you. Liquid nitrogen ice cream.
Tell me how it tastes.
Very nice.
Yeah, is it like normal ice cream?
Very smooth, Andrew. Yeah, it's very good.
And no calories either. Thank you so much, Greg. We'll catch up with you later.